Good evening, happy Friday, and yeah, let's get started, I guess. All right. Okay. Uh, all right. Ah, okay. Let's continue with our journey of disproving special relativity. So it's let me put it this way. Uh, Science is a tricky thing. So what we have here is two competing candidates. Okay, it's analogy between science, physics, and politics. Okay, so let's say two competing candidates. What are they? They are propositions. What is a proposition? It is a statement that is either true or false. This first order logic. Alright, so first order logic got integrated into mathematics, probably in late 1800s, early 1900s. Okay, so proposition is basically a statement that could be either true or false. So it's a Boolean term, Boolean constant, or Boolean variable. Okay, it could be either true or false. It's binary. Okay, that's what proposition is. So we have Einsteinian proposition and Galilean proposition. Okay, and both of them cannot be true. One of them has to be false. They are mutually exclusive. Okay, so it's like election, it's like voting in politics. Okay, people have freedom who to vote for. Okay, so whether they're gonna believe in Galileo or Albert Einstein, it is people's choice. It's their right. It's their freedom. Okay, so Mr. Einstein and Mr. Galilei, they are competing candidates. Okay, so actually it's Einsteinian proposition and Galilean proposition. Okay, they are competing for one seat. Just like public office, out of two candidates, only one of them can be elected and have that public office, just like in politics. Okay, so let me grab some toilet tissue to wrap up my. It'll be very interesting paper. Okay. Yeah. So, physicists they may say I'm kind of like softcore and kind of like coward. Oh, you don't have got to write things in what the LaTeX. You're afraid of that. You're lazy. You're afraid. You're a coward. Maybe that's what they're gonna say about me. Oh, you're afraid. You have no chance of publishing a physics journal, so that's why you choose to publish in a political science journal. Well, the thing is, it's about interaction between politics and science. Okay, so that's why political science is a better place to publish. Okay, so and yes, I don't wanna learn LaTeX. Okay, I just don't have time. Okay, and I don't like writing in LaTeX. I have before, just a little bit, right? I don't like it. Okay, I like Microsoft Word better. Why? Because the way it's like WYSIWYG. What you see is what you get. Yeah, WYSIWYG. What you see is what you get, right? Yeah, but LaTeX is not like that. Okay, it's like code behind. Oh my goodness, I don't need that. Why? I did enough computer programming in my life. Okay, so yeah. Now, yeah. So yeah, so LaTeX is kind of like it's Markov language. It's like HTML. Okay, so or XML. So Einsteinian proposition is this: in vacuum, speed of light is absolute. So that's why time has to bend. Okay, to preserve the relative speed of light. If relative speed of light should be absolutely fixed, then it's the time that needs to be modified. Okay, that's Einsteinian proposition. The speed of light is absolute. Relative speed of light is same as speed of light. So that's Einsteinian proposition. Okay. Now, but special relative theory, without proving, they assume that proposition to be true. So it became an axiom. That's Einsteinian proposition being axiomized. What is axiom? It's something that is assumed to be true. Why? Because it's just too obvious, right? So that's my objection to Einsteinian axiom. I don't see it as an axiom. Einsteinian proposition that speed of light is absolute. To me, there's no rhyme or reason to think so, unless Mr. Einstein, and people of his kind is very religious people. They worship light. I mean, even Jesus, he liked light. He said, "You are the light. I'm the light of the world." Right? Jesus loved light. And some ancient Egyptian religion, they worshipped sun god, right? Yeah, some religion worship sun or light in general, right? But it's supposed to be physics, science, not religion, okay? And religion, Mr. Einstein, he himself was not that religious at all. He didn't practice Judaism. He was not religious. He was not exactly atheist either. He was just not interested in religious thoughts. Religion was not in his mind at all. Okay, so he was just doing science, right? So, I mean, Michelson-Morley experiment, they failed to measure the relative speed of light being different from speed of light, right? Maybe experimental error or design defect. Experimental design defect, because speed of light is such a big number, right? Maybe it's just not easy to measure that tiny little difference, relative speed. Okay, that would be my guess. Okay, so that's the Einstein proposition. Now, the competitor, Galilean proposition is this. When the main way to state this, okay. Because I looked it up. Yeah, Galilean invariance is there's Wikipedia article about that. Okay, so it was nice. Okay, yeah, it got some useful links and yeah, it was nice. So Galilean proposition is that out in the sea, smooth, calm sea, like where there's no island, not a single cloud. Okay, there's just no sense of direction out in the middle of the ocean. Okay, if you're floating on a calm sea on a boat, there's no way to tell whether you're standing still or you are moving with constant speed. Okay, so that's Galilean proposition. And corollary of that is this, okay? If two objects, let's say going like this, okay? If they're moving out in the ocean, that was his original analogy, okay? I mean, out in the sea, okay? So let's expand that a little bit. If two boats are moving like this, the only thing they can measure is relative speed. And it is equivalent. And there's no way to tell the difference between Adam standing still and Bob moving to the left, or Bob standing still and Adam is moving to the right, or both Adam and Bob are moving to the left and to the right. Half the speed, okay? So there is no difference. They are equivalent scenarios, and there's no way to tell the difference. So that's the Galilean proposition, okay? And in 5 to 10 minutes break after that, we're gonna do just that, okay? And why those two propositions are incompatible. One of them have to be false, okay? And it won't be a complete proof actually, okay? It's up to the people to choose what proposition should be elected as the axiom, the truth that we can just take for granted, we can just assume to be true. Why? That's what axiom is, okay? It's something we have to assume to be true because there's no way of proving it. Like 1 plus 1 is equal to 2. That's like by definition, right? That's kind of like axiom like thing, okay? So we cannot prove whether this is true or false. 1 plus 1 is 2, okay? Because we just take it for granted. We assume it to be true, right? So that's what axiom is. It's something we cannot prove to be true. Why? Because it's just obviously true. Like two parallel lines will never meet. That kind of things, okay? All right. Let's take a break. All right. Okay, let's take 5 minutes. So let's talk about mathematics. All right. So because that's yeah, we are doing physics, but mathematics and physics very much interrelated, right? So I mean, mathematics or calculus came from physics, right? Yeah. So did linear algebra, like dot product. They all began as a physics concept, okay, like work, you know. So yeah, and well, linear algebra it also has like matrix, right? That came from more like the optimization problem, okay, system of equation, right? So like linear programming, okay. So that's how matrix came about, okay. So system of equation, okay. So, linear system of equation, yeah, that's how matrix, the whole linear algebra came about, okay. So yeah, that's not quite physics, all right. So anyways, so uh axiom is like this. Okay, two parallel lines never meet. Maybe it's not axiomatic. Maybe we can prove that because what's the definition of two lines being parallel? Well, the perpendicular line, the distance between 2 points in two different lines, if we say equal for all the points, then it's parallel. Okay, and so we can prove that from that definition that two parallel lines never meets. Why? I mean, proof by contradiction, right? If it meets at some point, and that point, yeah, the distance is no is zero, and some other point distance is non-zero, right? Contradiction. Okay, so it's proof by contradiction. Okay, so it's not axiomatic. Okay, I'm sorry. Yeah. Now, so what's the axiom? Axiom is a groundwork, starting point. You are building a house, right? Ground level. That's what axiom is. And mathematical proof or mathematical theories is a house, is a building, and axioms are at the bottom level, foundation. Okay, that's what axiom is. So Einstein theory, like special relativity, like E equal mc squared. That's like higher floor. Axiom, yeah, speed of light being constant. Okay, and my argument is that that foundational axiom is false. So this entire house of Einsteinian special relativity will collapse. That will be my prediction. Okay. Yeah. General relativity. Yeah, its axiom is the what they call as principle of equivalence, right? The inertial mass and gravitational mass is equivalent. Okay, it starts from there, the foundational level. Okay, and I argue that that foundational axiom is false. So that's why I predict that entire house of general relativity, including theory of black hole, will collapse. Yeah, because everything starts from that wrong axiom. Okay, so yeah. So that's our job here, and that's my job, or our job if you join me, okay, by being here, okay. So, yeah, so that's what we're doing. We're demolishing the wrong house, okay, because they're not built on strong foundation, okay. I mean, Saint Paul said, yeah, Satan can come as angel of light, right? So special relativity theory is about light, speed of light, and yeah, it's beautiful, but so what? It's wrong. Okay, so we're gonna demolish their house, both special and general relativity. What can I say? We do what we gotta do, right? Yeah. We are sorry. Some people built their academic career all their lives. They studied special and general relativity, So, we are sorry to hurt their feelings, but yeah, most likely our theory here will not be widely accepted. Perhaps it will get buried, like stillborn baby. That's fine. Whatever. We do what we can, right? To share the truth that we know, that we discovered, share it with others, okay? I mean, we are not trying to destroy somebody else's academic career. We are not that. So when Mr. Galileo came up with his theory, he was branded as a heresy. His books were banned by Catholic churches. It's one of the 11 books that were illegal to read. Okay, it was that bad, okay? Just like Mr. Charles Darwin, his evolution theory, okay? Yeah, heresy. Illegal to read. And so, but my prediction is this. When I finish writing this, okay, most likely it will be even published. It will just dismissed, disregarded, ignored. So it won't be even banned or branded as heresy. No, I think it will just remain unknown. That's how it has been in my life. Okay, I made a movie. People just don't watch it, just ignore it. Okay. When I write, after I publish my book, they just don't buy it. They don't pay attention. Okay, so it just gets buried. Huh? It's always been like that in my life. Right? Just a handful of people, kind and generous people, purchase my books online, watch my movies. Of course, my family friends, I mean family members and friends, did watch my movie. It's just a handful of people, okay, but general public, not interested, never heard of. But that's fine, okay. Yeah, we do what we can, and that's it, and we move on. All right, so, okay. So, yeah, this morning I kind of woke up early, and yeah, I made some progress in our theory. Okay, yeah. Let's give it a name. So inertial equivalence. Yeah, theory of inertial equivalence. Yeah, something like that. Yeah. So we'll start with the Einsteinian assumption. Okay, so time dilation. All right. So you have lambda factor. Okay, so let me look at my note that I jotted down early this morning. What time? 5 o'clock in the morning, something like that. Yeah, I was kind of thinking about this. Okay. Okay. I just copied down here. Okay. So, in Einstein world, A is static and B is moving, right? And A has long train, okay? And on the wall of the train, which is static, is parked, but B's train is moving, okay? A's train has this photoreceptor laser sensor, okay? And when laser beam hits that one point, it records the time. Okay? What time that laser beam hit this specific photoreceptor, okay? Alright. Because B is moving, let's say our time dilation factor lambda is 1 over 2, like 0.5. So when A's time go from 0, 1, 2, 3, 4, B's time goes from 0, 1 over 2, 2 over 2, 3 over 2, 4 over 2. Okay? Because time B, and B is moving, okay, is time A, well, delta t, okay, delta t, over 2, okay, according to Mr. Einstein. So, B's train, it is just one point in B's train, is a single point, okay? Should I throw laser every second? Zero second, 1 second, 2 second, okay? So, according to Mr. Einstein, A's train records the time of this photoreceptor receiving the laser beam from B's train is 0, 2, and 4. Okay? Right. We'll take 5 minutes break, okay? I need some vocal rest. So, and then we'll do the second scenario when B is static and A is moving the other way. Why don't you try that, okay? Yeah, draw a diagram like this if you want to, okay? And compare. Okay. This is fun stuff. I like doing this, okay? So, thanks to Mr. Einstein's error, we are having a lot of fun disproving his theory. Okay, so we all in somewhat, right? Probably Mr. Einstein in heaven will be very proud of us, even if we are disproving his life work. Okay, so I'm sure he's still proud of us. Right? We like him. He's cool. I like him. I think he's a cool guy. Okay. Let's take a break. Okay. So I read about like last night or earlier this morning, like I read about before I went to work. Okay, so I read about this Wikipedia article about Galileo Galilei's Magna Carta, whatever. His main book, okay, that he wrote in Italy, in Italian, or maybe Latin, because he has rich patron who supported his living, okay. So he was dedicated to the something like Signore Ferdinand something, okay. So maybe he was gentleman, maybe businessman, maybe he made a lot of money doing business in Italy, like international trade, or maybe he also inherited a lot of money from his ancestors, or maybe both. I don't know. Maybe they're family business or something. I don't know. But it was very nice of support the living of this poor scientist, right? Yeah. Very cool. Hmm. Now, okay, let's do this. So, so that's scenario number one. Okay, where B is moving. Mr. Bob. Okay, Robert. Right. Second scenario, Adam is moving. Okay. Let's start from here. All right. So, Bob standing still. Okay. And Adam is moving. Okay. Yeah, but B has a long train himself. Okay. So now, what's happening is this: his train is not moving, but A's train is moving. Okay. In one single point, B shoot out the laser beam, and Adam's train has photoreceptor, laser sensor. Okay. All the way, all the way. Okay. Linear laser sensor. All right. Kind of like strip. Right. So yeah. And Adam's train uh, shoot out this laser beam once per every second. Okay. So yeah. So A's train maybe it's just photofilm, right? The silver, whatever, or maybe it's digital, whatever, right? Silicon based, which is long strip of sensors, photo sensors, okay? And whenever this laser hits A's train wall, it records the time, okay? Yeah. So what would it look like? Now, B is standing still, so time 0, time 1, time 2, time 3, time 4. 1 second, 2 seconds, 3 seconds, 4 seconds, okay? Now, let's get rid of delta, okay? Because it always start from 0, so yeah. Okay? Now, it goes like this because A is moving and the time dilation factor is 0.5. The time clock in A's train, whenever it hits this train wall, okay, is 0 over 2, well, 0 over 2, 1 over 2, 2 over 2, 3 over 2, and 4 over 2. Okay? Which is not the same as 0, 2, 4, then it will be like what? Let's do some more, okay? So they're yeah, they're not the same numbers, right? So uh, it's not exactly disproof because it depends on what axiom, what proposition you vote for to be axiom, to be self-evident, to be the truth, right? But I would vote for Mr. Galileo, not Mr. Einstein. Why? Because it makes more sense, right? Yeah, we'll explore this. This paper, I think I'm gonna limit this paper subject to relativity because it is relativity and politics itself. It's gonna take long pages. Other subjects, uh, we're gonna have to make into some other papers. Okay, so we'll see how it goes. Okay, so maybe politics and science, volume one. Yeah, politics and science, volume one. Physics, politics and physics. Okay. Next volume will be like politics in like science, volume two, like climate change. Next volume will be about LGBTism, and next volume about marijuana, something like that. Okay, yeah, but this volume one will be about relativity. Okay, because it's gonna be long. Just relativity of itself alone. So, yeah. Okay, so we don't care what speed v is. Maybe it's half of light speed. We don't care. All right, it's just going to the east, going to the west, going to the east with the same speed, but opposite direction. Okay, so and according to Mr. Galilei, there should be no difference whatsoever. All right, because A standing still and B going that way with let's say 10 meters per second, and B standing still and A going that way, the other way, 10 meters per second, there should be no difference. And I agree with Mr. Galilei, there should not be any difference. Why? Because they are equivalent. And I think that proposition, inertial equivalence, uh, which is known as a Galilean invariance, that should be voted for as axiom, self-evident truth that does not require any proof. That we can safely assume to be true. Right? Yeah, that's my opinion. Okay, so I'll vote for Mr. Galilei, not Mr. Einstein. Okay. So, as we'll see later on, Einsteinian theory of special relativity absolutely make no sense. I share with you one by one. Okay? Yeah. It's very, very self-contradictory from the very beginning, right? So, and we'll explore. I share it with you, right? It makes absolutely no sense. Okay. Yeah. You understand what I'm saying? If not, don't worry. It's not that important. Okay. It's just physics. Alright? Yeah. It's for the entertainment's sake, intellectual entertainment. That's what this is. We are just having fun, okay? We are staying out of trouble, alright? So, yeah, it's all about fun, okay? So, yes, let's write it out then, okay? So, Then how come Mr. Einstein's obviously wrong theory has gained such a wide acceptance in the world? Uh, Possibly out of sympathy for the European Jews who went through Holocaust and anti-Semitism. Okay, so it's like action reaction in Newtonian physics, right? So you have anti-Semitism, and after that, there comes pro-Semitism, perhaps hyper-pro-Semitism. Okay, out of sympathy for the past generation of Jews who have been uh, persecuted. Okay, so that's one possible explanation why Mr. Einstein's theory gained such a wide acceptance out of sympathy, perhaps, of the anti-Semitism. Okay, that's one explanation. Second explanation, yeah, his theory is very interesting, surprising, shocking, mysterious, challenging, right? Yeah, yeah, I did study some of his theories. It is very interesting. Okay, so but the time has come that people need to know the truth. All right, so yeah, that's what we're doing here. Okay, so, yeah, yeah, I had quite a long day. Okay, so I'm kind of low energy. Okay, yeah, at work, lawyer job. Yeah, it was busier than average. Today was busier than average. Okay, so that's kind of low energy. Okay, but happy Friday, happy Friday. All right, let's take 5 to 10 minutes break. Okay, so yeah, yeah, and I explain what this means to you. Okay, all right, we continue. Yeah, let's take a break, okay? Or do you want me to explain this to you? I can. Informally. So it's like this, okay? Out in the universe, outer space, we draw a big curtain, big box where there are stars out there, right? But we are gonna block all that starlight so that it's completely dark. So that, and there's Adam, astronaut, Bob, also astronaut. They have flashlights, okay? And let's say this in this room, there's no gravitation, okay, and no light except for their flashlights, okay, and they're plenty of oxygen, okay. Don't worry, they're not gonna suffocate, okay. So just out in the space, you have this curtained box with plenty of oxygen, right? And they're just floating in the space without any gravitation whatsoever. Okay, they call it in physics Einstein's cabin, whatever. We're not gonna call it that. Okay, yeah, we just call it space box. Space box. Oh boy, I'm carrying this cushion in my clothing. I'm gonna turn on the heater. It's getting too cold. So, in this space box, again, there's no sense of direction. East and west, that's just naming convention, okay? What's east and what's west, okay? On planet Earth, there's North Pole, right? It's magnetic, right? So yeah, you have compass, which is magnetic, so it points to north, right? And you look at the star, you have northern, whatever that, what's that name of the star? North Pole star, whatever. Yeah, you have this northern dipole that revolve around that northern star, right? Yeah. But in space box, you're not gonna see anything, okay? And there's no magnet, there's no planets around. It's just empty space. So compass is not gonna tell you anything, and you cannot see the northern star, okay? It's just dark, right? And Adam and Bob, they have no sense of direction, right? Out in the space, there's no such thing as east and west, north and south. No. Okay. It's all naming convention. Okay. There's no sense of direction. Okay. Now, so when Adam and Bob moved like this, kind of passing each other, they are not colliding, but they are passing each other. Okay. They're moving through to opposite directions. Okay. And then they cannot tell who is moving. Maybe they are both moving. Maybe one is standing still and Bob is moving, and maybe Bob is standing still and Adam is moving. There's no way to tell. That's why I would vote for Galilean axiom, not Einsteinian axiom. Okay. Because if we assume Einsteinian axiom is true, then yes, there should be time dilation. Why? Because relative speed of light is constant. That's the Einsteinian axiom. Result of that axiom is time dilation. Okay? So if we assume Mr. Einsteinian axiom is true, then there comes a result that contradicts Galilean axiom. Why? Because If Adam is standing still and Bob is moving that to the west, then Adam is recording this laser flashlight laser beam 0, 2, and 4 seconds. Second time mark. Okay? But second scenario, when Bob is standing still and Adam is moving to the right, to the east, whenever Bob's train shoot out the laser beam every second, Adam will record. We'll give it different color. Zero, 0.5, 1, 1.5, 2. This guy. Yeah, we'll write as 0.5, okay? And 1.5. Okay? So it's not symmetric. It is asymmetric in these two scenarios. So that Einsteinian axiom results in contradiction of Galilean axiom. So that's why they are incompatible to each other. Okay? In scenario number 1 is this, okay? Because Bob is moving, according to Mr. Einstein, his time slows down. Flip side of that is, because Bob is moving and Adam is standing still, compared to Bob's time, Adam's time is faster, goes faster. Time speeds up compared to Bob's time. In Adam's point of view, Bob's time slows down. In Bob's point of view, Adam's time speeds up. That's when Bob is moving. Okay? Second scenario. Adam is moving, Bob is standing still, but Adam is moving to the other opposite direction. Okay? In that case, Adam's time slow down. Compared to that, I mean, Bob's point of view, yeah, Adam's time is slowing down. But in Adam's point of view, it's Bob's time that's speeding up. Compared to Adam's clock. Okay? So it's asymmetric. Right? Adam's clock, okay, so we give it a label, alright? This is when Adam is standing still. So, small t of Adam. And the second row, that's when Adam is moving, so it's big T, capital T. Time of Adam when Adam is moving. That's our notational convention, okay? And they are different. But in both scenarios, Bob's train shoot out the laser beam every second according to Bob's time, Bob's clock. First scenario, Bob is moving uh, toward the left, west. Second scenario, it's Adam that's moving to the right, toward the east. Okay? And the two scenarios give us different results according to Mr. Einstein. That's why Einsteinian axiom and Galilean axiom cannot be both true. They contradict each other. One of them has to be false. Okay. It's like election, okay? You can only vote for one person. Okay? No. Yeah, you can vote for both people in our new voting system, fractional voting system, right? But only one person can win the election because they are competing for the same seat. Okay? So that's the analogy. Right? Maybe I should submit this to physics paper, okay? I don't know. Maybe I should learn LaTeX, okay? Because it's not that difficult a language to learn, okay? I'm a former computer programmer. Yeah, I can learn it, all right? And it's not full-blown language. It's markup language, just like HTML, okay? Yeah, but we'll see. Maybe I have to learn it, okay? Ah. What they should is they should come up with maybe it's already there, some GUI, graphical user interface for LaTeX, okay? Even if it's not free, just make it more user friendly, okay? So that that's what they should do. All right? Maybe it's some out there. Maybe it's not free. Would I be willing to purchase it? Yes. If not, it's not too expensive. Okay, so maybe it cost me like $50, maybe $100. It's LaTeX GUI, graphical user interface, so that it's easier to write things in LaTeX format. Okay. Okay, we'll take 5 minutes break. Okay. Then and we'll stop and restart. Okay. So, all right. See you soon.